Not like the minus signs of the last one. Those we can cancel out due to a technicality. This one, unfortunately, can't go any further than this, okay? Alright, yeah, but as I was saying before, if these things had no solution, this would be a negative square root there, and you would just stop. You could go no further. And what that means is the two things didn't cross each other, okay? In fact, let's take a look at an example of that. Yes, Linda?
How did you get the 11 underneath the radical?
11.
11 plus 220.
Oh, that's a good question. It should be 100 times 2 plus 220. You're absolutely right. So, I don't know how I got 11 there. Must have had 11 on the brain. Okay. But it doesn't matter. It comes out to 3. Yeah, it's still positive, so it still has a solution.
I was wondering.
Does that mean I can now factor out a 10 again? No. Unfortunately, still no 10 to be factored out here. Sorry. 10's, you're stuck with that 10. Alright. I think that was more like 10. Yeah. Alright. Any questions about that though? Let's take a look at a quick example of one that doesn't work. Okay. We'll do two parabolas this time. Well, no, let's do a parabola and a circle. Our parabola will make x squared plus 4, okay? And for our circle, we'll choose the circle x, I don't know what matters, x plus 1 squared plus y plus 4 squared equals 1, okay? Now, if I were to quickly sketch these, I would clearly see these things don't cross each other, okay? This parabola is entirely above the x-axis, and this circle is entirely below the x-axis, so they should never cross each other. But if I tried to actually work these out, okay, I could use the substitution method, okay? Stick x squared in for the y down here, okay? That'll give me x plus 1 squared plus x squared plus 4 plus 4 squared equals 1. We work on cleaning this up some. This right here becomes x squared plus 2x plus 1. This over here would be x squared plus 8 squared. Okay? So this will be x to the 4th plus 16x squared. Okay? Plus 64, it's all equal to 1, okay? We go ahead and we enter that, we clean this up some further. We'd have x to the 4th, okay? Plus, let's see, x to the 4th plus, 17 x squared plus 2x plus 64 equals 0. Okay? And now, if we're doing this one by hand still, what we'd have to do is we'd have to go through and find some way to factor this one out. I don't know a way to factor this out. What I would do in this case actually would be look for all the use a rational zero test. If you guys remember that, and go through and look for all those. Okay? You know, using synthetic division to clean that up. Huh? Where did I get the 64? No, there's a plus 1 here, 64 and minus 1, so it would be, so those ones would actually cancel when you 64, okay? Anyway, but I would go back and use those tests that we learned when we were dealing with multivariable equations, or these types of equations before. To speed things up, all I'm going to do is use my calculator, okay? So I'm going to bring up the calculator. Oops. Let's read it. Okay? And what I can do with the calculator at this point is put in x to the 4th plus 17x squared plus 2x plus 64 and see where it crosses the x-axis. Okay? So, x to the 4th, okay, plus 17x squared, okay, plus 2x plus 64. We'll go ahead and we graph that. Oh, I gotta fix the graphing window. Ah, so lame. Come on. Alright, zoom, standard. And I got a blank graph, didn't I? What does that mean? You get a blank graph. Richard?
It's not in the window.
That means it's not in the window, which means what? Does it cross the x-axis in this case? No, so if it doesn't cross the x-axis, does that mean does this thing have real solutions? No, it doesn't, okay? So we know that there is no solution to these things.
Wait, can it cross the x-axis, like?
Outside the window?
Yeah.
I suppose so, but I mean really, realistically, we have a plus 64 on the end of this thing. It means it's been raised up 64 spaces.
Right.
Even if we did zoom out or zoom fit, that's an option. Zoom fit, okay, basically says make the graph fit into the calculator window. We can see it comes close. It should be this big parabola type thing, right?
Yeah.
But does it cross the big parabola type thing? Oh. Down here at the very bottom, when x is 0, it never crosses going either way. The lowest, in fact, the lowest, in fact, that it gets is 64, actually. Okay, and it shoots back up again. So it doesn't, indeed, it doesn't actually cross at all the x-axis. Okay. All right. So, kind of using calculator ANUS, we know that this has no solution. Okay, which means that these things did not cross each other. Okay, so because there's no solution, the two graphs never cross each other. Okay? Alright, any questions there? Yeah? You'll have to watch the video. Okay? That will be on YouTube later today. Sorry. Or get notes from a classmate. Okay. What we're doing is we're solving nonlinear multivariable equations. We actually looked at this on Thursday. Okay. So we're just kind of going back over it again, more through it. Okay. All right. My last example is we're going to take a look at one by graphing. Okay. And so by graphing, we're going to do x squared plus y squared equals 4, and y equals 1/2 x. Okay. And we're going to do this graphically. And we could use a calculator, or if you're at home at your computer desk, you could use a online graphing utility. And I have a suggestion of one to use right here at www.demos.com. That one's a free one. Okay, free. You don't have to register for it, and it works great.
It's also the first thing that pops up when you're typing graphing.
Does it?
Yeah.
Cool. Did not know that. Okay. All right. And so here's what I went ahead and did here. Was earlier I graphed both equations. There's x squared plus y squared equals 4, and there's y equals 1/2 x. Okay, our two equations. We've graphed them. Okay, set them equal to each other, and basically all we're looking for is where they cross each other. And the nice thing is the graphing program will tell us the exact location. They cross each other at 1.789 and 0.894. That's 1 point, and then same point, but with both negative. Okay? And so there you have it. And want to see how that worked out nicely? Okay. Now, problem with this though is, while this is a nice handy utility to use while you're doing homework, in class or on a test, you're not going to have that, basically available to you. Okay? And that's where the calculator comes in handy. Okay? So what we'll do instead is we'll use the TI calculator to do the same thing. I go to the graphing window, and I just plug both those things in. The first one's easy enough to plug. It'd be 1/2, okay, x, that's what we're going to graph. Or actually, I'm just going to make it 0.5x. That way the calculator has no issue. Okay. Now the second one though, x squared plus y squared equals 4, is a little bit trickier to enter in. Okay. The reason why is our calculators don't handle things with y very easily. So what I'm going to do actually is I'm going to rewrite the equation for the calculator by basically getting it to be y equals. Okay? So I'll have y squared equals 4 minus x squared. That means y then is going to be equal to plus or minus the square root of 4 minus x squared. Okay? Okay? Now with that in mind, I can enter them in to my calculator here. So I'll enter in two graphs actually, one where it's positive and one where it's negative. So square root of 4 minus x squared. Okay. And then negative square root of 4 minus x squared. Both parentheses. Okay? We go ahead and we graph these. I'm going to have to rezoom the window. So zoom standard is the sixth option, so zoom standard. There's my line. Okay? And there's my circle. And if you can see here, it crosses at two locations. One's right there, and one's right there, right? Now, I'm going to ask the calculator to tell me what those two locations are. I do that by going to the second count menu, and my fifth option says intersect. That will allow me to find where the two lines cross each other. Hit enter. I'll ask you for your first curve, first line, we're on it, so we'll hit enter. Second curve, this will be the upper part, this will be the positive version. I'll choose it, and I'll say guess, help it figure out the answer by highlighting it right there. It does its magic, and it gave me 1.788888544 and then 0.89442719. Okay? If I compare this to the online graph, the point is actually the same point. Okay? The only difference is this one's been rounded to 3 decimal places.
The circle also looks bigger.
Okay?
It's more circular.
Well, yes, and that's because this is has proper scaling. Well, this one, the y's are at a different scale than x. Okay. All right. Okay. We can do it for the lower point where it crosses. We do the same thing. Okay. We say intersect. First curve will be 0.5x. Second curve now will be y3. We'll enter that. Now it'll ask us for the guess. Where my guess is over here. It does its magic. Gives me the same point that the online graph gave me. Okay? So we found it both ways. Okay? Any questions on how that worked? Now, do keep in mind here, if I've got more than one graph, I'll have to choose the correct graph for finding the intersection. You can do that by just scrolling with this right here. That lets you scroll through all 3 graphs. Okay? Any questions? Yeah, we got it. Alright. Good stuff. Alright. Kind of the last thing with these things, okay, besides graphing is, these, so far all we've looked at are basic things like circles and parabolas and things like that. Okay. We can actually use this method for any sort of equation whatsoever. Okay. If we looked at, we could use the graphical method to find any random sort of ugly equations. So basically, this next example, what we're going to go ahead and do is we're going to find where y equals 1 over x squared and where y equals ln of x cross each other. Okay? Okay? Now, we can do this graphically by just entering this in straight up. Okay? That is, graph both of those and figure out where they cross each other. Another way I could do this graphically, though, is if I tried initially to solve this by hand, okay, using substitution or set equal method. We'll use set equal here. Okay? I said, well, I can set these things equal to each other and solve. That would be 1 over x squared equals natural log of x multiplies both sides by x squared. That gives me 1 is equal to x squared natural log of x. Subtract 1 from both sides. And that gives me 0 is equal to x squared natural log of x minus 1. Well, uh-oh.